In today's lesson, we're going to find the volume if we know the cross-section is perpendicular to one of the axes. What does that mean? Well, here we have a circle, and we're going to build upon it different figures. So what happens if I were to create a square perpendicular to the x-axis here? Well, what would happen is I go from one edge to the other, perpendicular through the x-axis, and that distance would be the side of each of my squares. So I'm going to go ahead and drop the y-axis here flat, and I'm going to show what this figure is going to look like. So there's my figure. I'm going to stop it for a second. So we've got from this point to this point is the side of one of my squares. I also know the distance up on this figure is the same as the distance here because I have a square. So I'm going to go ahead and continue to create that figure so we can kind of see what it's going to look like. And we should see kind of a dome figure created. I'm going to do it one more time here just to kind of show you what it looks like. And then show that solid. So notice our top is kind of curved, and then our sides come around on that circle as well. So what do we notice about this figure? Well, hopefully we should see that each of those figures along and perpendicular to the x-axis is a square. So how would I come up with the volume of this? Well, to find the volume, I would go ahead from this point to this point, or my two endpoints. We can call this A and call this B. So we can add all of these areas up. How do I add a bunch of areas together? I can do that through integration. So I'm going to integrate from A to B of each of these squares. How do I find the area of a square? The area of the square is going to be side squared. So I'm going to take the integration from A to B of the distance between these 2 points. And the distance between those 2 points is going to be the distance or the equation of this function minus this function, which we'll look a little more in depth at the math behind it in our examples. What I'm going to do at this point is just kind of look at some other figures that are created. Here we're going to take a circle again with an equilateral triangle. So again, I'm going to drop my y-axis. I'm going to go ahead and create that figure. So notice I've got a bunch of equilateral triangles. Hopefully remember, I'm going to go ahead and show that solid. Hopefully remember the area of an equilateral triangle is radical 3 over 4 times the side squared. If I slide my triangles, I should see I've got a bunch of triangles. So now I can go and integrate, again, from my 2 endpoints, my A to my B, of the area of each of these triangles. I'm going to go ahead and toss it over here. We're going to have now a right triangle. And we can build upon any figure that we want. So I drop my y-axis. I'm going to go ahead and create my solid. So here, we're going to create semicircles upon this figure, this triangle. So now we're going to be adding a bunch of semicircles. And we're going to add each of those areas together from point A to point B. And to find that, it's going to be 1/2 the radius. What do I know about the radius as I look at this figure? Well, the radius is half the diameter. And in this case, my diameter goes from this y-axis all the way out to the equation of this line. So I would have to go ahead and take half of that. That would be my radius. How do I find the area of a circle? Well, in this case, I have a semicircle, so I have 1/2 pi times the radius squared, in which case the radius is half the distance from my 2 lines. Again, we'll look at the math here in just a little bit.